River water quality, E. coli. How do you know how a river is affected with E. coli or not? We're taking a look at Stats NZ to understand more. How is it measured? So, Escherichia coli or E. coli in river water is one of the 5 indicators that provide an overview of New Zealand's river water quality and how it changes over time. And you can apply these to different rivers as well. So, ELI concentrations measured at monitoring sites and model for New Zealand's river length for the period, a comparison of E. coli concentrations at monitored sites and the proportion of human modified land cover in the upstream catchment area. Also, how measured and modeled median E. coli concentrations compared to trigger values determined by McDowell, which indicates the risk of environmental impairment, predicted risk of campylorial infection, as shown by the medium concentration, 95 percentile, and percentage of results above 260 and 540 colony forming units above 100 milliliters compared to the National Objectives Framework bands related to human contact. So, why is it important, and what do they find? So E. coli is a type of bacteria commonly found in the intestines of warm-blooded animals, including people, and E. coli in freshwater can indicate the presence of pathogens, disease-causing organisms from animal or human feces, and the pathogens can cause illness for anyone who ingests them. For example, during swimming, Campylobacter is one of the most common pathogens associated with animal and human feces, but it is difficult to measure. Also, we use E. coli concentrations measured by colony-forming units to infer Campylobacter infection risks in the waterways. And we can see the information right here of the E. coli and the key find. And we have the measured concentrations of E. coli by NOF human contact band right here for A, B, C, D, and E in colored form in the measured data and the human modified land cover. And for the periods of 2016 to 2020, median E. coli concentrations did exceed the trigger values and indicate a risk of environmental impairment based on the comparison. As we can see here, the human modified land cover and upstream catchment, and we can see the different statistics here. And at a 28% of monitored sites for 15% of New Zealand's river length based on model data. Also, measured data shows that 66% of monitored sites had an average Campylobacter infection risk of more than 3%, with 32% of the sites exceeding a risk of 7%. And model data show that 45% of New Zealand's river length had an average Campylobacter infection risk of more than 3%, with 22% of New Zealand's river length exceeding a risk of 7. And monitored sites with a predicted average Campylobacter infection risk of more than 7% had an average proportion of 80% human modified land cover in their upstream catchment area. And this portion is 2.8 times higher than for monitored sites with a predicted average risk infection of 1% NOF band A, which had an average proportion of upstream human modified land cover of 28%. Also, trends are classified as improving or worsening, where the trend is likely or very likely, and we use the term indeterminate where there is either no trend direction or not enough statistical certainty to determine trend direction. And measured data for 20-year trends showed a similar proportion of sites were improving, worsening 41% at comparable rates, and for the rest of sites, 21% of the trend was indeterminate. That being said, this is interesting to see how they did a statistical analysis to measure E. coli, and that is very helpful in understanding that. So it's always a good idea to periodically test and take a look at Campylobacter and the amount of E. coli in your water.